Hello, my name is Titus Ngatich, and in this lesson, we are going to discuss on alkali earth metals. Remember, in alkali earth metals, they are found in group 1 of the periodic table. Examples are, we have lithium, 2, we have sodium, and 3, we have potassium. So these are the elements that are found in group 1 periodic table. We want to see the atomic radius of these elements down the group. We have what we call the atomic radius. Atomic radius is the distance between the nucleus of an atom and the outermost energy level occupied by an electron. For example, we have this. We have lithium. So when we say the nucleus, we are talking about the center part of these alkali metals to the outermost energy level occupied by an electron. So we define atomic radius as the distance between the nucleus of an atom to the outermost energy level occupied by an electron. So this is the outermost energy level. For lithium, it's here. For sodium, it is here, and for potassium, it is here. So if you see the distance, that is atomic radius. So we want to compare as we go down the group to the atomic radius increase or decrease. As we move down the group from lithium all the way to sodium, the atomic radius increases. The reason is, as we move down the group, the number of energy levels increases. Therefore, the distance between the nucleus and the outermost energy level have increased atomic radius. In conclusion, as we go down the group, the atomic radius increases. We want to see what we call the ionic radius. In alkali metals, they react by losing only one electron. If you use, we see the electron configuration of lithium. We have 2 to 1, 2 to A to 1, and 2 to A to A to 1. You can as well use S and P notation. That will be your assignment. Use S and P notation on the electron arrangement of these elements. So, in lithium, they lose one electron. Sodium, they lose one electron. And for potassium, they lose one electron, forming what we call the ionic radius. Remember, they want to be stable. So they have to lose one electron to attain stability. They have to lose one electron to attain what we call stability. So the ionic radius increases. The ionic radius increases down. We want to see what we call the melting and boiling point of these alkali metals. We are going to see 2 want activity. And 3, we want to see on how to store, so the storage. We can as well add the softness of this alkali method. The softness. So melting and boiling point. As we move down the group from lithium to potassium, the melting and boiling point decreases. The melting and boiling point decreases. The reason is there is an increase in distance between the nucleus and the outermost energy level. And in melting and boiling point, we are breaking these bonds. So if you compare the bond between lithium and potassium, the bond of lithium is high as compared to that of potassium. That's why as you go down the melting and boiling point decreases. For potassium, distance, we want to break the bonds. So the distance here is high or large. But for lithium, the distance is low. And in melting and boiling points, we want to break these bonds. So in conclusion, we can say the decrease down the group. We want to see the electrical conductivity. Alkali metals, they have the one outermost electron, which is delocalized. When we say delocalized, they move freely. They move freely. For lithium has one as well as this and this. So they move freely. So in conclusion, we can say in alkali metals, they conduct electricity because they have what we call delocalized electrons. The storage. How are we going to store these alkali metals? Alkali metals, we store them in oil or in paraffin because they react mostly with oxygen and water. So we have to store them in oil or under paraffin. So we store in oil or paraffin to prevent them from reacting with oxygen and water. We have what we call the softness. Alkali metals, they are soft. But as we go down the group, the softness increases. So if you cut lithium compared to sodium and you compare to potassium, potassium can be easily cut because the bonding is loose or weak as compared to that of lithium. So the softness increases down. In summary, electrical conductivity, they conduct electricity. Storage, we store them under paraffin because they react with water or oxygen. Softness increases down the group because as you move down the group, the bond decreases because there is an increase in distance between the nucleus and the outermost electron. Therefore, it can be easily cut. We want to see what we call chemical properties. Chemical properties of alkali metals. Chemical properties of alkali metal. So, when sodium metal is ignited, it burns with a yellow flame to form a white solid of sodium oxide. So when we start with sodium, it produces a yellow flame and a white solid of sodium oxide. If we write an equation, sodium plus oxygen, it will produce sodium oxide. If we balance the equation, this one will be 4, this one will be 2, this one is solid, gas, solid. So this one is white solid, and the flame is yellow. Then when air is enriched, when we say enriched, it means there is an excess oxygen. So when air is enriched with oxygen, sodium will react with oxygen to produce what we call sodium peroxide. So sodium will react with oxygen to produce what we call sodium peroxide. Sodium peroxide. So if we balance the equation, we have 2. This one is solid, gas, and solid. So when there is an excess oxygen in air, there is formation of sodium peroxide. So we have sodium oxide. When sodium oxide is reacted with water, it forms sodium hydroxide, and this sodium hydroxide is alkaline solution. Alkaline solution, it is basic, and basic solution turns red litmus paper blue. So sodium oxide reacted with water, it will form sodium hydroxide, and this sodium hydroxide is alkaline, and alkaline means and basic turns red litmus paper to blue, and blue litmus paper will remain to be blue. We want to see how potassium reacts with oxygen. Potassium plus oxygen. It will produce potassium this potassium plus oxygen to produce potassium oxide. If we balance the equation, gas, this is solid. What's the color of the flame? The color of the flame is lilac. The color of the flame is lilac, and it will produce a solid, and the color of the solid is white. So the color of the flame is lilac, and the color of the solid is white. We want to see how these alkali metals react with chlorine gas. So when we react alkali metals, for example sodium plus chlorine, it will produce sodium chloride. It will produce sodium chloride. And if we react for potassium, it will produce potassium chloride, and for lithium, it will be lithium chloride. So in conclusion, we can say when alkali metals react with chlorine gas, it will produce their corresponding metal chlorides. And their metal chlorides, for example, lithium, it is lithium chloride. For sodium, it is sodium chloride. And it is for potassium, it is potassium chloride. We want to see on how they react with acids. Reaction of alkali with acids. So when we react alkali with acids, it will produce a salt and a hydrogen gas. For example, lithium reacting with HCl or hydrochloric acid, it will produce lithium chloride plus hydrogen gas. So we have salt and a hydrogen gas. For sodium, it will produce sodium chloride plus hydrogen gas, and for potassium, it will produce potassium chloride plus with dilute acids, it will produce salt and hydrogen gas, and salts are, for lithium, it is lithium chloride, sodium chloride, and potassium chloride. So we want to finalize on what we call how they react with water. How they react with water. Let me summarize on how these alkali metals react with water. When alkali metal reacts with water, they produce a hissing sound, and they produce hydrogen gas, and also they produce a solution which is alkaline. And when we say alkaline, it is basic. So the first observation is it produces a hissing sound, hydrogen gas, and alkaline solution, and it moves or it dances on the surface of the water. So let me introduce Madam with alkaline earth metals. Thank you.
My name is Madam Maka. I'm going to continue the lesson. I'm going to handle alkaline earth metals. Okay, I'm going to handle alkaline earth metals. And a brief introduction. Alkaline earth metals are group 2 elements, or rather they are elements found in group 2 of the periodic table. So they are group 2 elements, and they are called alkaline earth metals because the name alkaline means when they form their oxides and their hydroxides, then they form basic or alkaline oxides when they are dissolved in water. And group 2 elements, they include beryllium, magnesium, calcium, strontium, barium, and radium. But because we are only focusing on first 20 elements, we are going to talk about beryllium, magnesium, and calcium. And beryllium has got a configuration of 1s2, 2s2. Magnesium, on the other hand, has a configuration of 1s2, 2s2, 2p6, 3s2. Calcium has a configuration of 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Now, after looking at the electron configuration of the elements in group 2, another thing that we're going to talk about is their physical properties. Physical properties. Under physical properties, we are going to talk about number 1, atomic radius. And ionic radius. We are also going to talk about physical appearance. We are also going to talk about hardness, electrical conductivity, and then we are also going to talk about melting and boiling point. Now, let us start with the atomic and ionic radius. Atomic and ionic radius, just as the teacher had said previously, that atomic radius is the distance between nucleus of energy level containing electrons. And ionic radius, on the other hand, is the distance between the nucleus of an atom and the outermost energy level when an atom has formed its ion. Therefore, when we want to look at the trend in the atomic radius and the ionic radius of group 2 elements, let us draw their structures and see how their atomic radius compare as you move down the group from beryllium to magnesium. Now, beryllium has got 2 electrons, 4 electrons. Therefore, the first energy level is occupied by 2 electrons, and the second energy level is also occupied by 2 electrons. Magnesium, on the other hand, has got this structure. And then we have calcium as the last one. I'm beginning with the atomic radius. you look at the normal configuration, and look at the atomic sizes of the following elements, even just by the physical appearance, you will realize that the atomic radius will be increasing down the group, or their sizes increases down the group, because beryllium has got 2 energy levels, and magnesium has got 3 occupied energy levels, and calcium has got 4 occupied energy levels. That means that their atomic radius will increase down the group because of the increase in the number of occupied energy levels. As you move down the group, each and every element has an additional energy level of 1, which makes their sizes to become larger. Now let us talk about the ionic radius. The ionic radius, on the other hand, is their radius after now they have formed ions. Let's draw them this side. Beryllium will form an ion, or all of the group 2 elements, they form ions by losing 2 electrons. Now beryllium forms an ion to remain with only 2 electrons. Magnesium also forms an ion by losing 2 electrons in the outermost energy level. Calcium forms an ion by losing 2 energy levels in the outermost energy level, and therefore these are the structures of their ions. When you look at both the atomic radius and the ionic radius, they both increase as you move down the group because of an increase in the number of energy levels. But when you now move down to comparing the atomic sizes and the ionic sizes, you realize that the atomic size of each element in group 2 is larger than their ionic sizes, because when they form ions, they lose energy levels, and therefore their sizes decrease. So the atomic radius of group 2 elements is larger than their ionic radius, because as they form ions, they lose an energy level. Now let us go to the physical appearance. Alkali metals, just like the alkaline earth metals, just like alkali metals, they have a shiny metallic luster when they are freshly cut, which when you expose it to the atmosphere, because of the presence of oxygen, they will react with oxygen, and that shiny luster will tarnish, or it will disappear after some time. That is why most of the time before doing an experiment, they will have to scrub the surfaces, because they react with oxygen readily. That makes their shiny metallic luster to disappear. And comparing their hardness of alkaline earth metals, they are less soft compared to alkali metals, which has been told in the previous lesson. Now, alkaline earth metals, they are hard compared to alkali metals, or you can say they are less soft than alkali metals. This is because when you compare the atomic size of alkali metals and the atomic size of alkaline earth metals have got smaller atomic size compared to alkali metals, and therefore their sizes being smaller is because of the increase in the number of protons, which will make the nucleus to attract the outermost electrons more and more towards the nucleus. Therefore, their sizes will decrease, and as the size of an atom decreases, it becomes less soft. And hardness in alkaline earth metals decreases down the group, because as you move down the group, now you realize that the size of the atoms increases. But we have said that hardness of an alkaline earth metal is measured by the size of its atom. So the smaller the atom, the less soft it becomes. And electrical conductivity, anytime you hear the word electrical conductivity, you talk about the localized electrons. That is when you are talking about metals. Metals will only conduct electricity when they have the localized electrons. Now, beryllium, magnesium, and calcium, which are collectively known as group 2 elements, they have got 2 delocalized electrons, each and every one of them. Therefore, we say that they are able to conduct electricity, or we say they are good conductors of electricity because they have 2 delocalized electrons. When we compare electrical conductivity between metals and alkaline earth metals, we realize that alkaline earth metals are better electrical conductors than alkali metals because they have more number of delocalized electrons. Therefore, when you are describing electrical conductivity in metals, the more the number of delocalized electrons, the higher the electrical conductivity. And the last physical property we are to talk about is the melting and boiling point. The melting and boiling point again of alkaline earth metals, we realize that the trend down the group, melting and boiling point, increases because as you move down the group, the size of the atom becomes larger. Therefore, the forces that hold the atoms together becomes less strong. We are able to say that as you move down the group, melting and boiling point decreases because the force holding the atoms becomes less and the size of the atoms also becomes larger. Therefore, the melting and boiling point decreases down the group. But magnesium has a usual low, it has a very unusual low melting and boiling point. And this is because naturally it has a crystalline nature. Therefore, its melting and boiling point is unusually low compared to the neighboring going to talk about reaction with chlorine and then lastly we talk about reaction with dilute acids. Reaction with dilute acids. Before we even start discussing the chemical properties of alkaline earth metals, it is important to note that reactivity of alkaline earth metals down the group, reactivity increases because of the decrease in their increase in their atomic size. As the atomic size of the group 2 elements becomes larger and the strength of the force that holds the atoms together becomes less, then that atom becomes more reactive. Therefore, we can be able to see that calcium having the largest atomic radius and being held by the most weak forces or most weak intermolecular forces, it is the most reactive group 2 element. Now, let us talk about the chemical properties, beginning with the reaction with oxygen. And we will realize that generally chemical properties of alkaline earth metals is similar to the chemical properties of alkali metals. Now, reaction with oxygen. When the group 2 elements are burnt in oxygen, they produce their oxides. For instance, when you burn magnesium in oxygen, magnesium will form its oxide, which is magnesium oxide. And calcium, on the other hand, when burnt in oxygen, also will form its oxide. Therefore, we can be able to collectively say that group 2 elements react with oxygen to form their respective oxides. Reaction with water and steam, on the other hand. Beryllium is unreactive with water, which means it does not react with water under normal conditions. Magnesium, on the other hand, reacts with water to form its hydroxide, which is magnesium hydroxide plus hydrogen gas. So it is also important to note that hydrogen gas. Hydrogen gas. We can see that calcium reacts as hydrogen gas. Then we also have steam, also react between a metal and steam. Steam water in. So a metal will react with steam to form a metal of hydrogen. Therefore, an example which we plus steam symbolic liquid magnetite plus hydrogen gas. Chlorine to form magnesium will chlorine chloride. There then that reaction all will because hydrochloric acid, the salt will be chloride. So chloride salt plus hydrogen gas. So hydrochloric acid will react with, for instance, magnesium will react with hydrochloric acid. Sorry, this should be salt and hydrogen gas. So magnesium form magnesium chloride plus hydrogen gas. And also, when a metal reacts with another dilute acid, which is called sulfuric 6 acid, it will form sulfate salt plus hydrogen gas. And an example, let's use for instance calcium reacting with dilute sulfuric 6 acid. It will form a sulfate salt, which is calcium sulfate plus hydrogen gas. Lastly, we have the dilute acid known as nitric 5 acid. So metal plus dilute nitric 5 acid will form a nitrate salt plus hydrogen gas. For example, magnesium plus nitric 5 acid forms magnesium nitrate plus hydrogen gas. Generally, the chemical properties of alkaline earth metals. So, I would like to bring the class to an end at that point because we have discussed most of the physical and chemical properties of alkaline earth metals. I'm concluding by reminding us of something that I never talked about when we were talking about the physical properties of alkaline earth metals, and that was in hardness. And we said that as an alkaline earth metal cannot be easily cut with a knife because it is described to be having a property known as ductility